Okay, now we are starting questions for NTSC. Chapter is magnetism. The first question is, if a wire is given to you, okay, and okay, now the question is that if at a point which is 4 centimeter away from the wire, the magnetic field is 10 raised to power minus 3 Tesla. Okay, so now you have to find the magnetic field at a point which is 1 centimeter away from the wire. So now we know that B from wire is equal to mu naught I upon 2 4 pi d sine theta 1 plus sine theta 2. When long wire is taken, obviously theta 1 is the angle made by this point with this ends of the wire. Okay, this is theta 1 and this is theta 2. So when long wire is taken, theta 1 equal to theta 2 equal to pi by 2. So simply the value will be mu naught I upon 2 pi d. Okay, now d is the distance from the center, so BA will be mu naught I upon 2 pi d is equal to 4 centimeter, यानी कि 4 into 10 to the power minus 2 meter, and B will be mu naught I upon this BA is given 10 to the power minus 3. So now this is equation first and equation second. So we can solve this equation by BB will be simply B upon DA, or simply dB 1 upon 4. So simply PB will be 4 times of BA, so it will be simply 4 into 10 to the power minus 3 Tesla. Okay, so simple here is the concept which is in this question is that when B is reversely proportional to 1 upon D, D is the distance from the center, then we can write down as B1 upon B2 is equal to D2 upon D1. Okay, so this is the concept for next. Okay, now in this question we'll have to find the location of the point where the magnetic field is 0. Okay, so here to find the location we will use simple concept. Due to this wire, suppose this is first wire and this is second wire. In the left side of the first wire, the magnetic direction of magnetic field due to first wire will be outward. Okay, this is the direction of P1 due to first wire, and the direction of B2 is also outward. So here net magnetic field will not be 0. The net magnetic field will be simply B1 plus B2. Okay, so when let the point where the net magnetic field is 0 is considered, let this point is x. Okay, so when x is less than 2, so B net will be B1 plus B2. When x is less than 2, then B total is outward due to B1 and B2. Okay, so when x less than 2, B net, this is B1 and this is B2, so overall outward, so will not be 0 anywhere. Means the point will not be before before the scaling 2. Now if we come to when x greater than 6. Okay, now this is the condition. So in this condition b net will be b1 plus b2. Now considering at this side, b1 is what? Simple, b1 is due to first wire, the magnetic field at b1 after 6 point will be inward, and b2 is also inward. So the net magnetic field will not be zero. This is inward due to b1 and this is also inward due to b1. So the net direction is inward. Okay, so net magnetic field will not be zero. Okay, at any location. But now come to this region. In this region b1, this is downward or into the plane, b2 is outward. Obviously the direction of both magnetic field are opposite to each other, so there will be net magnetic field when x less than 6. Then b net will be b1 minus b2. Okay, now I am considering this x point at anywhere. Let this point is at this location. Okay, so now I consider the distance x from first wire, and the location of this point will be from the second wire. It will be 4 minus x, because the distance between these 2 points is 4 unit. So this will be 4 minus x. Okay, so now magnetic field at this point, let this point is p. So at this point p, b1p and b2p, it should be 0. So now the value of this b1p is what? Simply mu naught I upon 2 pi d. D is what? Simply x. Okay, and this is where the direction is inward. Okay, minus mu naught I2 is 3i upon 2 pi. This is 4 minus x, and this is outward, and this should be equal to 0. So simply if I can solve, I upon x should be equal to 3i upon 4 minus x. Cancelling this down, the x will be 1. Okay, means the distance of that point will be 1 unit from wire 1. So the point will be where? The location of this point is at this point. Okay, so this is our point, which is the desired point. Means this is the actual location of p. Okay, okay, now the question third is like, if suppose a helium nucleus is revolving in any circular path which has the radius 0.8 meter. Now you will have to find the magnetic field at the center of this radius, at the center of this circle. So we know that magnetic field at center of any circle will be mu naught I upon 2r. Here r is the radius, so I can write it down as simply capital R. Now mu naught is equal to I is equal to q by t. Okay, 2r is simply 2r. Now the charge which is revolving, this charge is what? Nucleus. Helium nucleus contains 2 protons, so the charge will be equal to of 2 proton. So 2 proton and the charge q of 2 protons, and time period is what? Simply the time period which is consumed to complete the cycle, and divide by 2r. Now putting the value, we can get mu naught 2 into 1.6 into 10 to the power minus 19. This is the charge of one proton. Time period which is given 2 seconds. 2 into 1.8. Okay, Now solving this, you can easily find this is equal to mu naught into 10 raised power minus 19 Tesla. This is the value of magnetic field at center. Now the deviation, suppose if radius is twice, okay, in this question, if this is assumed that if radius of circle is increased by 100%, so B will be changed or not. Okay, so to find the answer of this simple effect, we will increase the radius. We know that B is reverse proportional to R. So in that case, when the radius is increased by 100%, means radius is twice, so B2 upon B1 will be simply R by 2R. Okay, because B is reverse proportional to R, so this will be cancelled out. So it B2 will be simply B1 by 2. So when radius will be doubled, the magnetic field at the center will be half. Okay. Okay, now the question is like that. It is a wire given to you. The shape is given as shown in figure. So in this wire, AB's part is straight line, CD part is also same straight line, and BC part is a half circle made by bending this wire. So there will be the center of that circle O. Now you will have to find the magnetic field at the center due to the wire CD. Okay, this is the first part, and the second part you will have to find the magnetic field at O due to part this BC, means the half circular part. So in this first part, we'll have to find the magnetic field at O. Now this point O is lying on the CD. O is along the length of wire CD. Okay, so here at O, the magnetic field, we know that when the point is along the wire, then their magnetic field will be 0. Okay, so BO is due to CD is 0. This is the simple theory. Okay, and at the second point, we know that BO due to half circle. Okay, this is the general formula for any phasing, any angle made by the circular arc. Now the angle made by circular arc at the center is what? It is simply pi. So the value of alpha is what? Pi. So now to calculate this, mu naught I upon 2r. Okay, alpha is simply pi and this is upon 2 pi. So pi to pi cancel out. This is mu naught I upon 4r. This is the value of the magnetic field at the center. Okay,